Hello, this is Eric Michael Loyd. I have a master's in psychology, neuropsychology concentration. Today I wanted to read an article from the Annals of Behavioral Medicine, a publication of the Society of Behavioral Medicine. This one is called Optimism and Physical Health, a Meta-Analytic Review. This article was published 2009, June of that year. Volume 37, issue number 3, page 239 through 256. It's the author's manuscript. The authors of this article, titled Optimism and Physical Health, a Meta-Analytic Review, are Heather and Rasmussen, Ph.D., Michael F. Scheier, Scheier, Ph.D., and Joel B. Greenhouse, Ph.D. Abstract, the background. Prior research links optimism to physical health, but the strength of the association has not been systematically evaluated. Purpose. The purpose of this study is to conduct a meta-analytic review to determine the strength of the association between optimism and physical health. Methods. The findings from 83 studies with 108 effect sizes, ESs, were included in the meta-analysis using random effects models. Results. Overall, the mean ES characterizing the relationship between optimism and physical health outcomes was 0.17. P-value is less than 0.001. ESs were larger for studies using subjective versus objective measures of physical health. So the effect sizes were larger for those using the subjective versus the objective measures of physical health, asking the people about their own subjective feelings of physical health rather than an objective criteria, such as in an item analysis from a survey. Subsidiary analyses were also conducted, grouping studies into those that focused solely on mortality, survival, cardiovascular outcomes, physiological markers, including immune function only, cancer outcomes, outcomes related to pregnancy, physical symptoms, or pain. In each case, optimism was a significant predictor of health outcomes or markers. All p-values were greater than 0.001. So all the p-values were greater than were lesser than 0.001. So that's greater than a 99% confidence interval, 99.9% confidence interval. Conclusions. Optimism is a significant predictor of positive physical health outcomes. So that is a short, concise, and sweet conclusion in one sentence. So if you had other things going on, you could skip the rest of the introduction and analysis of the article, but that is the conclusion. Optimism is a significant predictor of positive physical health outcomes. For everyone else, the introduction. Interest in the relationship between personality characteristics and physical health has increased substantially over the past several decades. Within this larger framework, a number of studies have explored the link between dispositional optimism, the generalized expectation that good things will happen, and physical well-being. Many of these studies have shown optimism to be protective. For example, research shows that optimistic people, compared to those more pessimistic in outlook, report less pain, better physical functioning, experience fewer physical symptoms, and are less likely to be rehospitalized following coronary artery bypass surgery. Although research on optimism and health has flourished, there has been no systematic review, qualitative or quantitative, of this specific nature. Thus, the nature of the association between optimism and physical health has not yet been explicitly assessed. This is an important oversight inasmuch as not all studies report significant associations. The purpose of the present paper is to provide quantitative meta-analytic review of the research exploring links between dispositional optimism and physical health. Two other recent reviews are relevant here. First, Pressman and Cohen provided a qualitative review of the literature linking positive affect to health. Although positive affect and optimism are determined, such as parameters or mortality. Although positive affect and optimism are related constructs, they're not the same. So they may be similar but not congruent. Thus, the focus of the review by Pressman and Cohen and the present review are distinct. Additionally, their review was qualitative, whereas the present review was quantitative. The second review, by Chida and Steptoe, examined quantitatively the association between positive psychological well-being and mortality. The review by Chida and Steptoe differs from the present review in that they defined positive psychological well-being quite broadly, including variables such as vitality, life satisfaction, and positive affect, in addition to optimism, inasmuch as sub-analyses were not concluded on specific predictors. It is difficult to tell whether optimism alone predicts health outcomes. Additionally, Chida and Steptoe focused on only one outcome, mortality, whereas the present review focuses on multiple outcomes. As stated, the primary aim of this paper is to assess the extent to which optimism is linked to physical health outcomes, broadly defined. In addition, the meta-analysis was used to gather information about two other areas of interest. First, we wanted to examine moderators of the relation between optimism and physical health. The strength of the association between optimism and health varies across studies. The meta-analysis was used to identify and evaluate potential reasons for these differences. One way to distinguish between the effect sizes of different studies is to take into account the manner in which physical health is assessed. The term physical health is quite broad and includes outcomes that reflect disease endpoints that are softer or harder in nature. For example, softer endpoints would include soft reports of symptoms or a clinical judgment about a disease state, whereas a harder endpoint might be mortality. Self-reported outcomes are very subjective in nature and rely completely on the respondent as a source of information. As such, these reports are influenced by a host of factors, for example, memory biases, other than underlying disease state. There are also important method of variance with the manner in which optimism is assessed. For instance, is it assessed via self-report, which is subjective. In contrast, harder disease endpoints primarily reflect outcomes that are biological in nature or outcomes that can be objectively determined, such as immune parameters or mortality. The present analysis assessed whether optimism is more strongly related to subjective than objective physical health outcomes. The studies reviewed differ in many ways, in addition to the type of endpoint that is assessed. The design of the study could also affect the ES. A significant finding in a cross-sectional study may or may not hold in a study using a prospective design that examines changes in the outcome across time. One could argue that different types of designs also offer research evidence that is more or less convincing, and that some study designs, for example, prospective studies, generally offer better evidence than do others, cross-sectional studies. Conducting separate analyses, aggregating studies based on study design, could be a useful way to identify variations in the ES of associations between optimism and physical health. Studies also differ in the type of participants that were sampled. Some studies sampled participants that were healthy throughout the study, while other studies sampled participants that were either acutely or chronically ill at the beginning of the study, or were categorized according to some specific health condition, such as pregnancy. Still, other research sampled participants that were healthy at the beginning of the study, and these participants may or may not have been healthy at the end of the study, for example, epidemiological studies of mortality due to certain diseases. Additional analyses were conducted distinguishing between studies that used healthy participants versus those that used patient samples to discern whether sample type makes a difference in the relationship between optimism and physical health. We define healthy participants as those who had no known disease or health problem throughout the entire duration of the study, and patient participants as those who were categorized according to a specific health condition by the end of the study, including research on survival and mortality. Moreover, the studies included in the database were quite diverse in terms of the types of outcomes measures that were used. Because of this, we also performed sub-analysis on clusters of studies that examined similar outcomes. For example, we separated studies that measured physiological markers such as intima media thickness, blood pressure, glycosylated hemoglobin, and immune markers from studies that measured disease endpoints or survival and mortality. We also conducted some analyses on several subjective outcomes of interest. In summary, subsidiary analyses were conducted on studies grouped according to whether they focused on mortality, survival, cardiovascular outcomes, physiological markers including immune function only, cancer outcomes, outcomes related to pregnancy, physical symptoms, or pain. A final difference among studies concerns the manner in which optimism was measured. Many of the studies used the Life Orientation Test, LOT, or revised LOT R, to assess the positivity of the generalized outcome expectancies that people hold. Peterson and Seligman have approached optimism in terms of explanatory style and attributional style questionnaire, ASQ, and the expanded attributional style questionnaire, EASQ, have been developed to assess optimism from this perspective. Still, other measures have also been used. The differences in the measures used to assess optimism may also account for some of the variability among studies. Analyses were conducted to explore this possibility. As noted, the meta-analysis had a further aim. In addition to evaluating the significance of several moderator variables of interest, specifically, it was used to gather information relevant to an issue that has emerged within the literature on optimism, but which also has implications for the link between optimism and physical health. That is, Scheier and Carver initially conceptualized dispositional optimism as being a single bipolar trait, with optimism at one end and pessimism on the other. Most people working in the field still continue to construe optimism and pessimism in this fashion and analyze their studies accordingly. However, a number of researchers have explored the possibility that optimism and pessimism are somewhat distinct constructs. This view is consistent with the fact that scales of generalized optimism are often shown to comprise two separate components, one measuring the person's expectancies for positive outcomes, his or her optimism, and one measuring the person's expectancies for negative outcomes, his or her pessimism. If optimism and pessimism are viewed as two separate constructs, it becomes possible to ask which one has a greater impact on physical health. Perhaps the effects in the more numerous bipolar studies, quote unquote, really are only due to the toxic effects of pessimism or only to the protective effects of optimism. See Robinson, Wellen, et al. Alternatively, perhaps both are equally important. The questions being asked here are reminiscent conceptually of the question that has arisen in the literature on affect, pertaining to whether it is better to construe positive and negative affect as bipolar ends of the same dimension, or better to construe them as two independent, albeit correlated dimensions. I don't know, that is a good question. I know that sometimes people could have what's called mixed emotions. Mixed emotions would indicate that those two emotions can be conceptualized as two separate constructs instead of on a continuum, pessimism or optimism. Some people have mixed emotions or experience two emotions at one time. And someone might, let's say, be at a wedding or at a funeral, for instance. Someone might feel sadness and someone might feel also happiness at the same time. That would be one real life example where you would have an example of positive and negative affect viewed as two separate constructs instead of on two ends of a continuum. The questions are also related conceptually to the ones asked in earlier research involving the type A behavior pattern and the attempt to identify which of the type A components was most predictive of heart disease, Matthews et al. To provide evidence on this issue, studies providing separate assessments of optimism and pessimism were analyzed separately for optimism effects and pessimism effects to determine if the two components were differentially related to health outcomes. Method: literature search and selection of studies. In order to identify studies to include in our review, we performed computerized literature searches using Medline and PsycInfo databases. The searches were performed through April 2009 using combinations of the following keywords: optimism, explanatory style, life orientation test revised, attributional style questionnaire, expanded attributional style questionnaire, immunity, HIV/AIDS, rheumatoid arthritis, lupus, autoimmune, multiple sclerosis, pain, pregnancy. The list goes on. Infertility, neoplasms, cancer, cardiovascular, coronary, cardiac, heart, hypertension, ischemic heart disease, atherosclerosis, endocarditis, cardiomyopathy, heart failure, cerebral vascular disease, anemia, stroke, diabetes, mellitus, renal disease, osteoarthritis, tuberculosis, respiratory, asthma, Huntington's disease, Alzheimer's, influenza, pneumonia, peptic ulcer, sleep, illness, physical health, survival, mortality, and chronic disease. Hope I said that well. We then used the ancestry method to locate studies that had not been identified in the computerized searches. Finally, we hand searched through the 3 journals in which we found the majority of articles published that included measures of optimism and physical health. Journal of Personality and Social Psychology, Health Psychology, Journal of Behavioral Medicine. We did not locate any additional studies through our hand search. We limited the search to only those studies that were published in English language peer-reviewed journals. Unpublished data such as doctoral dissertations and conference abstracts were not included. This search identified 132 studies that were considered for inclusion in the meta-analysis. Studies were then searched to determine whether they met the following additional inclusion criteria. The study had to have a measure or measures of dispositional optimism. Thus, studies were omitted if the expectancies measured were not generalized in nature, but rather limited to a particular domain or disease outcome. For example, expectancies about how quickly life would normalize following coronary artery bypass graft surgery. 2. The study had to include a measure or measures of physical health outcome. The study number 3 had to have some type of ES statistic, effect size statistics, such as a correlation coefficient, or statistics that could be transformed into an ES, for example, a t-test. And the sample size had to be reported. Were there 30 people in the study? Were there 300? Were there 3,000? We included studies with subjective or objective health outcomes. Subjective health outcomes include physical symptom reports, pain reports, and physician ratings of health status. Objective health outcomes include objective health records, survival, immune parameters, and various other biological outcomes. Since we were interested in the relationship between optimism and physical health, we did not include studies that only since we were interested in the relationship between we did not include studies that only assessed mental health parameters, for example, distress or anxiety. Using these criteria, 84 studies were included in our analysis, with a total of 108 effect sizes. Wow. That's quite a bit of studies. Coding. Each study was coded for the following participant characteristics: type of sample, healthy participants and cancer patients, mean age of the participants, gender percentages, and racial and ethnic category percentages. The following methodological characteristics were coded: date the study was published, design of the study, optimism measures used, outcome measures investigated, and the nature of covariates included in the analysis, if any. A brief explanation of our coding of the study designs is warranted here. Although many of the studies were described by their authors as prospective studies, we categorized many of the author-identified prospective studies as longitudinal studies, long-term studies, purposes for the meta-analysis, for the purposes of the meta-analysis. Many of the authors described their studies as prospective when they measured optimism and physical health across time without controlling for baseline physical health measures. Following Cohen et al., we consider a prospective study to be a form of longitudinal study that assesses the associations between a predictor at one point in time and an outcome at a later point, controlling for the association between predictor and outcome at baseline. For the purpose of this meta-analysis, studies were only coded as prospective if they included A, data presented in the article indicating the sample was equivalent in health at the beginning of the study, or B, baseline physical health was controlled for in the effect size calculation between optimism and later health outcome, or C, the sample started out as healthy at the beginning of the study and developed subsequent illness or disease thereafter. In many instances, we could not extract the previously described prospective ES information from the information presented in the chapters. Rather, the data were often reported as measuring the relevant variables as controlling for baseline physical health. So they controlled for baseline physical health in relevant articles. Readers should be aware that we used our coding scheme to classify studies in the tables that are presented, and that our coding scheme may be at odds with the coding scheme used by the authors. So it seems that they noted some of their potential limitations, which is great, as I've definitely read some articles that haven't noted any limitations, which is not standard practice and completing research analysis. Calculation of effect sizes. We calculated effect sizes based on statistics published in the original reports. Effect sizes are presented as correlation coefficients, R, in the table. Not all studies presented correlations between optimism and health outcomes. Thus, other statistical information was converted to correlation coefficients. Student T and F values were transformed into correlations using formulas provided by Lipsey and Wilson. If no statistics to calculate and effect size were presented, we searched the article for a relevant p-value, from which we calculated a t statistic and an R equivalent using the formula R equivalent equals the square root of t squared over t squared plus, in parentheses, n minus 2. 4 studies reported odds ratios, which were converted into correlation coefficients using the formula R is equal to the odds ratio minus 1 divided by the odds ratio plus 1. 2 studies reported only that their findings regarding optimism and health outcome were non-significant and did not provide further information for calculating an effect size, or ES. The results from these studies were assigned an R of 0. This is a conservative approach, as there is seldom zero correlation between two constructs. If the article did not include an effect size or information to calculate an effect size, the author of the study was contacted directly for the effect size information. We contacted 24 authors. 3 authors were contacted about more than one manuscript and several ES possibilities, or effect size possibilities. 20 of the authors contacted replied that they would attempt to address our requests. 2 were unable to provide effect size information due to no longer having access to the data. 15 provided us with effect size information we requested, and 3 failed to respond following several reminders after their initial agreement to provide the information. Meta-analytic procedures. We converted all test statistics into Fisher z-scores. We converted all test statistics into Fisher z-scores before conducting the analysis. Mean effect sizes were transformed back into RS for presentation after all analyses were conducted. Each study contributed only one effect size per analysis in order to maintain the assumption of statistical independence. When a study contained more than one effect size, such as longitudinal studies with multiple follow-up points on the same outcome, we computed the average effect size to avoid violating the assumption of statistical independence. We used a statistical package for the social sciences macro, MEANES, to conduct the meta-analysis. Several different sets of analyses were conducted in order to aggregate across studies. The sign of the effect sizes were changed as needed to make them consistent across studies. Such transformations were necessitated because some of the health outcomes measured, for example pain, were negative in nature, and some of the outcomes measured survival time were positive in nature. The first planned analyses were conducted on the overall relationship between optimism and physical health, aggregating across all studies. We expected that optimism would be significantly related to physical health and that the ESs in this analysis would be heterogeneous. The second set of analyses categorized studies in terms of the kind of physical health outcome examined, whether the outcome studied was objective or subjective in nature. We expected that optimism would be more strongly related to subjective measures of physical health than objective measures, which reflected harder disease endpoints. Those harder disease endpoints are things such as mortality, once again. Third, we conducted analyses aggregating studies based on study design, cross-sectional, longitudinal, or perspective. As we expected, that the study design would moderate the relationship between optimism and physical health. We then conducted analyses aggregating studies based on sample type, healthy versus patient. We also conducted separate analyses for studies that looked only at mortality, survival, cardiovascular outcomes, physiological markers, including immune function only, cancer outcomes, physical symptoms, pain, or only at outcomes related to pregnancy. We also performed analyses aggregating studies based on the type of optimism measure used. Different measures of optimism have emerged from somewhat different theoretical perspectives, and it is possible that these differences in measurement instruments may moderate the relationship between optimism and physical health. Specifically, we separated analyses based on whether the studies used a LOT or LOTR, ASQ or ESQ, EASQ, that is, or C, one-item measures of optimism. Finally, we conducted analyses comparing effect sizes for those studies providing separate assessments of optimism and pessimism. These analyses were conducted as it remains unclear whether their heightened optimism is protective, heightened optimism is risk-enhancing, or if both factors were important in understanding the links to physical well-being. Each effect size was weighed by sample size before conducting analyses, as studies have a larger sample size. Studies that have a larger sample size provide a more accurate estimate of the true population parameter. We calculated both an unweighted mean effect size and a sample size weighted mean effect size for each analysis. There were no differences between the mean effect size for the analysis. Thus, we only present the weighted mean effect size in the results. Analyses were conducted using a random effects model, as our goal was to be able to generalize the findings beyond the studies included in the meta-analysis. Random effects models calculate means and confidence intervals that generalize to all studies in a research area, as opposed to fixed effects models which cannot be generalized to the entire domain of studies. The random effects model enables generalization beyond the observed studies because the model assumes that population parameters vary between studies and attempts to estimate this variance. This estimated variance is combined with subject-level sampling error and is used to compute standard errors and confidence intervals. With more variance, the confidence intervals calculated using a random effects model will be larger than those calculated using a fixed effects model. Using a random effects model, though, provides a conservative test of significance of combined effect sizes, whereas inappropriately applying a fixed effects model when it is not appropriate can yield erroneous, narrow confidence intervals. I wonder if they did post-hoc analysis on that. Primary analysis I guess they didn't state it. Primary analysis used unadjusted effect sizes to estimate the association between optimism and health. We used unadjusted effect sizes because that was the only information available for the majority of effects. Although adjusted effect sizes were sometimes available, the primary analysis used only unadjusted effect sizes in order to use the same metric for all effects that were included. Subsidiary analyses were also conducted, however, to determine whether effect sizes were also significant when only including effects that were adjusted for covariance. To do this, effects were placed into one of three categories: those that did not adjust for covariance, those that were adjusted for demographic and/or health risk covariance, and those that were adjusted for some or more psychosocial covariance such as depression or negative affectivity. 62.9%, 19%, and 18.1% of the total effects available for analysis, respectively. The overall analysis was then repeated, breaking effects down into these three categories. Similarly, subsidiary analyses were conducted stratifying effects according to whether they reflected a subjective health outcome for an objective health outcome. Additional analysis. We conducted t-tests and f-tests that paralleled the aforementioned meta-analyses. First, we compared effect sizes between objective and subjective measures of physical health to investigate whether the type of health outcome study results in different effect sizes. Comparisons also were conducted after aggregating the studies by design, cross-sectional, longitudinal, and perspective. Similarly, we compared healthy versus patient samples to discern whether the type of participants sampled in the studies might result in significantly different effect sizes. We also compared effect sizes between studies using different measures of optimism and studies that measured optimism and pessimism separately. Finally, we conducted f-tests to determine if effect size varied as a function of whether the effect was conducted after to determine if effect size varied as a function of whether it adjusted for covariance or not. Variables that covary or vary together. Results. The appendix provides a descriptive summary of each study utilized in the meta-analysis, including the total number of participants, the sample type, optimism measure used, physical health outcome investigated, and effect size. These data are split according to whether the physical health outcome assessed was objective or subjective in nature. Some studies are listed more than once, as they report multiple correlations between optimism and physical health measures. The majority of the studies consisted of longitudinal, 35% of the sample, and perspective designs, 28% of the sample. The remainder of studies included was cross-sectional, 35% of the sample. Some of the longitudinal and perspective studies also included cross-sectional data. 44 of the ESs, or effect sizes, 38% in total, involved correlations between optimism and objective health outcomes, and 73 of the effect sizes, 62%, involved correlations between optimism and subjective physical health outcomes. The majority of the studies, that's 78%, used the LOT or LOT-R, that's LOT-R, to measure optimism. When judging or interpreting effect sizes, 0.10 or 0.10 is considered a small effect. 0.30 is considered a medium effect, and 0.5 is considered a large effect. Overall, analysis of effect sizes for optimism and physical health. The first analysis included effect size of all studies with the goal of providing an overall mean effect size of the relationship between optimism and physical health. This analysis revealed a mean effect size of 0.17. K is equal to 108, N is equal to 30, 133, 95% confidence interval is at 0.15 to 0.20. The true value at 95% confidence interval would lie anywhere between 0.15 and 0.20. Thus, optimism was significantly related to physical health outcomes based on all the studies examined. The p-value was greater than 99.9%. Not surprisingly, the analysis showed that the test of homogeneity, Q value was 343.49. The p-value was 0.000, was also significant, suggesting that the effect sizes in the overall analysis are heterogeneous. Accordingly, the planned moderator analysis were conducted in order to identify the source of some of this heterogeneity. Moderators of the relationship between optimism and physical health. Objective and subjective measures of physical health. The mean effect size for optimism and subjective measures of physical health outcomes was 0.21. K is equal to 65, N is equal to 11, 772, 95% confidence interval, 0.18 to 0.25. So the true value at a 95% confidence interval lies anywhere between 0.18 and 0.25. And the mean effect size for optimism and objective measures of physical health outcomes was 0.11. The K was equal to 0.43. N is equal to 18, or 18,361. The number of subjects were 18,361. At a 95% confidence interval, the true value is anywhere between 0.09 and 0.14. Just to go back to that last measure that I read, to get that number correct, was the sample size was 11,772 for the previous one as well. Thus, the effect sizes for both subjective and objective health outcomes are significantly different from zero. Both had a p-value of lesser than 0.001. That's significantly different from zero. Very significant. The t-test conducted to compare the effect sizes for subjective and objective health outcomes revealed that the mean effect size for objective measures was significantly smaller than the mean effect size for subjective measures. T is equal to 106, equal to negative 2.89. The p-value is equal to 0.005. Thus, the type of health outcome assessed moderates the relationship between optimism and good health. Study design. We conducted analyses for optimism and better health after stratifying by study design. The mean effect size for optimism and health outcomes was 0.22. The K was equal to 37, and N, the sample size number, was 8,443. At a 95% confidence interval, the true value lied anywhere between 0.18 to 0.26. That's where the true value lies between. For cross-sectional designs, 0.18, K is equal to 38 for the cross-sectional designs, N is equal to 5,692, and at a 95% confidence interval, the true value is anywhere between 0.13 to 0.22 for longitudinal designs, and 0.12, K equaling 33, N is equal to 15,998 at a 95% confidence interval, 0.09 to 0.15 for prospective designs. Each of the mean effect sizes was significantly different from zero. All p-values were lesser than 0.001. We tested the significance of the differences between the effect sizes using analysis of variance. The analysis did not reveal any significant differences. F of 2 at 105, those values were at 1.73, and the P is equal to 0.18. Inspection of the mean effect sizes, however, reveals that the differences are ordered in the expected direction, with the effect sizes for prospective studies being the lowest. Consequently, a secondary analysis was conducted. For this analysis, cross-sectional and longitudinal studies were combined because they suffer conceptually from the same set of limitations and compared to studies that used prospective designs. So, they were combined, the longitudinal and cross-sectional studies, because they have the same conceptual limitation, and then they were compared to the prospective study designs. So that covers all three of the designs included in this meta-analysis. The mean effect size for optimism and health outcomes for cross-sectional and longitudinal studies combined was 0.20. K is equal to 75. N is equal to 14,135. At a 95% confidence interval, the true value lies anywhere between 0.17 to 0.20. The mean effect size for cross-sectional and longitudinal studies combined was not significantly larger than the average effect size of 0.10. For prospective studies, T at 106 is equal to 1.70, with a P equaling 0.09. The confidence interval for that same set, a 95% confidence interval, is negative 0.01 to 0.11, although the difference approached significance. That difference did approach significance, however, it did not reach that. Type of sample. For this set of analyses, we separated the analysis based on the type of participant sample in the studies, for example, healthy versus patient, to discern whether the sample type was a moderator for the studies using healthy samples. The mean ES for the relationship between optimism and health was 0.15. K is equal to 39, N is equal to 22,369. At a 95% confidence interval, we have the value of 0.12 to 0.18. So that means that the true result lies anywhere between those two numbers of 0.12 and 0.18. For studies using patient samples, the mean effect size for the relationship between optimism and health was 0.19, K is equal to 69, and N, the number of participants included, were 7,864. At a 95% confidence interval, the true value is anywhere between 0.16 and 0.23. 0.03. So there's 95% confidence that you can find the true value between 0.16 and 0.23. Both effect sizes were significantly different from 0. Both the p-value were less than 0.001. The follow-up t-test indicated that the mean effect size for healthy samples was not significantly different than the mean effect size for patient samples. T at 106 equals a negative value of negative 1.09 with a p equaling 0.27, indicating that the sample type is not a moderator of the relationship between optimism and health. So it didn't indicate that the sample type was a moderator, which I view as perhaps the white ball when you're playing pool. So if you're using the pool stick as one variable, A, and the 8-ball corner pocket as the variable C, then the white ball would be the moderator. That would be a visual example of that concept. Separate analyses were also performed for the studies that looked only at the following: mortality, survival, cardiovascular outcomes, physiological markers, including immune function only, cancer outcomes, physical symptoms, pain, or outcomes related to pregnancy. For purposes of these analyses, we kept the studies with prospective designs separate from the studies with cross-sectional and longitudinal designs, but combined the latter two groups. These analyses show that optimism was linked to the vast majority of health outcomes that were assessed, including mortality and survival. Only 4 analyses failed to find an effect size greater than 0, and 2 of these 4 were close to being significant. For example, involving cross-sectional and longitudinal studies of immune function, the p-value is 0.07, and those involving prospective studies of cancer outcomes, the p-value is 0.053. The link between optimism and health seemed most tenuous for prospective studies of pain. The p-value is 0.18. So it appears that they didn't have as much of a link in those studies because the p-value was too high for those studies. Type of optimism measured. I'm going to read that part. Type of optimism measured: optimism versus pessimism, unadjusted versus adjusted effect sizes, and the rest of the article, which looks like it's about 34 more pages or 33 more pages in the next video, because I don't want to make these videos too long. I hope that there's something that can be gleaned from that as well. Thank you so much. It's Eric Michael Loyd. I have a master's in psychology, neuropsychology concentration. Thank you again for your time.